Welcome to my channel. I'm in coaching center. Today I'm going to explain your 10th standard science chapter 13 magnetic fields of electric current part 2 video. So let's come to the chapter. So next topic of your chapter after solenoid. So solenoid, the strong magnetic field of in a solenoid. That is called as magnet, and this magnet is called as electromagnet. That magnet we get in solenoid. So next topic is force on a current carrying conductor. Force on a current carrying conductor. Force, putting force on a current carrying conductor in a magnetic field. On a current carrying conductor, putting the force. So till now we have learnt about magnetic field. Learnt about magnetic field. Till now we have learnt about magnetic field. So what means a French scientist? A French scientist whose name is Andre. A French scientist whose name is Andre Marie Ampere. He suggested, so a French scientist whose name is Ampere, he suggested to that magnet should put equal and opposition force. It should put equal and opposite force on the current carrying conductor. On if a thing is carrying current, on current carrying conductor it should put equal and opposite force. He said carrying conductor, equal and opposite force should be done. And he also did a experiment. This experiment he has did. What he did means, you can see here, he taken a rod. So this says that this by seeing this, we say that the displacement of current carrying aluminum rod. So that is current carrying aluminum rod that is put in the photo. Current carrying aluminum rod. It is aluminum rod. Current carrying aluminum rod that is placed in magnetic field. See here, magnet. This is horseshoe magnet, they call it as. It is not a bar magnet, it is a horseshoe magnet they call. On that they placed this. Near that they placed this rod. Here you can see, that is aluminum rod. They placed near that. And what they did they placed, and the direction of force is reverse. It is reverse to the direction of the current. So the direction in which the current is coming, it is reverse on the direction of force. The force direction is reverse of the force direction of the current. So I said that now change the poles of magnet. We can see that the force on a current carrying conductor changes. The force on that it is carrying current, that changes. We can see that. So next is Fleming's left hand rule. So now you learn about right hand rule. Now Fleming's left hand rule. Fleming is the scientist who found that left hand rule. So let's know about Fleming's left hand rule. After this, let's come to the Fleming's left hand rule. So in this photo, the Fleming in an experiment, he shows that the consider that what happened means we consider of the current and that the magnetic field is perpendicular means 90 degree perpendicular to each other. He said that magnetic field and current is perpendicular to each other, and force is perpendicular to both. Perpendicular to both the magnetic field and current. It is perpendicular, and this is called as left hand rule. So stretch the first what you have to do means stretch the thumb. First you stretch the thumb, then you have to take the forefinger of your forefinger. First you have to take it, forefinger and middle finger of your left hand. You should take the forefinger, middle finger and the thumb left hand, and the first finger point, and the first finger should be perpendicular. Its direction the first finger is the magnetic field. And the magnetic field, the first finger, and the second finger is current. The first finger is magnetic field, the second finger is current, and the thumb is direction of the motion. Thumb is the direction of motion, on which the motion is happening, on which direction the thumb indicates. Fleming's left hand rule say that the thumb shows the motion, and the forefinger shows the magnetic field of the current, and the middle finger shows the current passing through which it is current passing, and the middle magnetic field and current should be perpendicular to each other. They should be like that. We have to keep. So next is electric motor. So you may have seen the motor in the fans, in your car, fans, many things you have seen. There will be motor. So the motor that converts the chemical energy into mechanical energy. It converts the chemical energy into mechanical energy. So they may ask, what is motor for 1 mark? This is the photo of a simple electric motor. So it has two poles. North pole and south pole, it has and it has a armature that is in rectangular shape, and it has a axe. There you can see axle, the round color there you can see, and it has a split ring. It has a split ring. It has a split ring, and it has two brushes. It has. So these all things the motor has here in this video you can see. So what happens means the two poles make the armature to rotate. Armature to rotate. This armature, the rectangular shape you are seeing in middle, A B C D, armature to rotate. So what happens means this side you are seeing, no, A B side. So A B side will come to the place of BC. It will come to the place, AB will come to the place of CD. AB side will come to the place here, AB will come to the place of CD, and the CD will come to the place of AB. Like that only it will rotate, and force of rotating that AB, by force of AB rotating, the current is produced. The current is send it to X. Here you can see, here X they have written. That's here wire that is connected to there, it will go to brushes, the wire that is connected, and CD opposes the going of wire, opposes that. And so this motor runs on Fleming's left-hand rule. As I said you about Fleming's left-hand rule. On that principle this motor run. You can see the here if you want. So see here correctly how means a device that reverses the flow. Of current, in a circuit is commutator. They may ask the 1 marks. Commutator, it reverses. And also what happens means, so see you keep your Fleming, say you take your left hand and keep on that, and see the current will is going from A to B and coming DC to, means it AB is bringing the current, and there is magnetic field. As you know in Fleming right hand rule, the magnetic field is on thumb. So thumbs here in north and south, they have magnetic field and current. And if you keep here on if you keep it straight, so you will feel that in this, if you keep, you will feel that in north and south the magnetic fields are there. And when you keep your the the middle finger, that is the current. See here on AB, so the current is flowing, and the motion thumb if you keep, there is motion happening here, you can see. So by this we can say that it is depending on Fleming's left hand rule. So they may ask this for 1 marks, on which the electric generator depends, on which principle they may ask, that is Fleming's left hand rule. So electromagnetic induction. Magnetic induction. For example, for that is here moving of a magnet in an electric coil. So when you put magnet in an electric coil, it moves and produces the current. So there will be current produced, and you can see it by deflection in galvanometer. There will be deflection in galvanometer. By that you can see. Here I did a mistake. So it is chemical, not electric. It converts the electric energy into mechanical energy. So next, so after remember that it converts the electrical energy into mechanical energy, not chemical energy into mechanical energy. So let's come to the next topic, that is Fleming's right hand thumb rule. So now I explain about Fleming's left hand thumb rule. In last topic I explained right hand thumb rule. In last topic I explained the Fleming's left hand thumb rule. Now right hand thumb rule, let's see about this. This is Fleming's right hand thumb rule. So it is also same as Fleming's left hand thumb rule. So the thumb indicates the movement of the conductor. Movement of conductor. The thumb indicates the movement of the conductor, and the forefinger indicates the magnetic field in that circuit or magnetic field. It indicates the magnetic field if we keep the hand, and as I said, it should be the middle finger should be perpendicular to the it should be perpendicular to forefinger, it should be perpendicular to forefinger, and the middle finger indicates the induced current. Induced current means it is the current that we get in generator. I will explain about generator. Induced current we get in generator, but in the right hand thumb rule we does not get the induced current, we get only the current. So next let's come to the generator, how generator works. This is the photo of a generator. So what it has means, it has two magnetic fields, it has two magnetic poles it has, and it has the armature, it has same, everything same, but there is some differences. Wait, I will say it has armature, as the armature is in the motor also, armature, and it has axle, but here it has slip rings. So here what it has means, so see, here it has split rings, so here we get slip rings. It has slip rings, it is called as slip rings, not split rings. So slip rings here we have. So keep in our mind, if we in anything, in any this circuit, if we put the split ring instead of slip ring, then it becomes the motor, or if we, in spite of split ring, we put slip ring, then it becomes generator. This is the simple thing you have to remember in your mind. And it has it has brushes, and also and also it has, 1 minute, has galvanometer. Here, see here, this you are seeing, no, this is a galvanometer which tells about how much current is producing, or positive to negative it tells about. It tells it has galvanometer. So this is depend on the principle of this generator is depend on principle of Fleming's right hand thumb rule. There the motor is depend on Fleming's left hand thumb rule. Here right hand thumb rule, it depends the generator. And no, not only that much, it depends, so it is it produce induced current, or more current it produce. As you know, more current is used to a generator, or used to when in the fields, or in shooting, or in the marriages. There they will keep the generator if the current is gone. You may see in that is because it gives more current. When so what happens means, this is also same, when the north pole and south pole both makes the armature to rotate from AB side to CD side, it will rotate, and it will rotate fastly. So at that time what happens means, the current will be produced, and it will be going to the galvanometer. It will be showing us where it is, how much it is produced. It will be rotating, the galvanometer will be rotating and showing us, and again it will come here to the slip rings, it will join, and again like that only it will join, and the current will be produced, and it will be stored in the there there only in the store. Domestic electric circuit. So what is this means? Domestic electric circuit. So you may have seen the current comes to your house. Current comes to your house. Your house. You may know that current comes to your house, but you may seen one wire is gone in ground. They have kept in ground. So it is due to earthing. It is called as earthing. You may have heard they may be doing earthing goes when they are making new house. So this is because you may not get current if there is problem in you may not get current shock. You may not get current shock if there is cut in insulator, if there is cut in insulation or the wire that is covered on that. You may have seen it is thicked because a copper wire is covered on the that on the wire where, so that they may be protected from your it may be your hand may be protected when you, if you mistakenly touch it, your hand may be protected. And also they make a thing so that sometimes because of short circuit the current may not supply, or if any at a time of any problem or short circuit you may not get any electric shock or thing. And the red wire is live wire. It is called as live wire that helps you to come the current that gives you current. And the black wire is neutral. It is called as neutral. This is the image. You can see the green wire is the earthing wire and the red wire is the live wire where the current goes, and the neutral wire you can see. So you may have heard about fuse. Fuse in circuit. Fuse, there may be fuse. So fuse, it helps in the time of overloading. So how it happens means when the live wire or the neutral wires that insulator is gone cutted, it's a little bit cutted, and when the both are touching, that time the current is passing in only one thing it is passing. So it will put pressure, it will put more pressure in you on the electric board, and at that time you will got short circuit or overload. We say overload occurs due to damage of insulator that protects the wire from getting protects that insulator that will protect you, as I said, that will protect us from getting shock, or it will protect us from getting overloaded or short circuit. This is called as short circuit. You may hear about short circuit happen. This is because of when the live wire and the neutral wire get attached with each other. That time we get because of overload of the current, there will be a short circuit in the current board. The fuse helps us by stopping the passage of current in the appliance. By stopping the passage of current in the appliance, it protects us from the appliance. It protects from short circuit. It protects from getting harm to appliance. It protects appliances. It protects the appliance from getting harm. Overloading, you may have heard. It happens due to putting of many appliances, due to putting or appliance, due to putting of many appliance in the socket. You may have seen sometime you may put some 5 or 6 switches in the socket. That time it may get overloaded. And we get overloaded, and that time also we will get the current will not pass correctly, because you may have put it 5 or 6 appliance switch that time. So for how much it can give? Only for 2 or 3. If you put that time means it will get overload. So that's why overloading we should not do. So this was your chapter, magnetic fields of electric current. So I explained about generator, electric on Fleming's left hand rule, right hand rule, and the electromagnet I have explained, and the magnetic fields 1 marks they will ask, and the right hand thumb rule, left hand thumb rule, and solenoid, and and the fuse, what is fuse as I said, and what is overloading, short circuit they may ask for 1 marks. Remember that. So okay friends, I will explain the next chapter in my next video. So I think you understand this chapter. Like the video, comment on my video, and subscribe my channel. I'm in coaching center for more video. I will see you in my next video. Till then, take care and have a nice day friends. Bye friends.